Sometimes your absolute value inequalities may yield no answer or all answers. So let me give you some examples. Say you have 3 absolute value of x plus 4 is less than 2. Well, we can solve this like an inequality by subtracting 4 both sides. 2 minus 4 is negative 2. And you have absolute value of x. If you divide by 3, you get negative 2/3. And when you see this, we were told to, whenever you have this less than a, we should translate it as x greater than negative a and less than positive a. But this is actually only true for a being positive, okay? You have to be careful. You can only use this when a is positive. If your absolute value is less than negative, there's a trouble with that, because I know that absolute value of x is always positive. So saying positive number has to be less than negative 2/3 is impossible. Okay, that means no x satisfies the inequality. So answer is a null set. So if there's no solution, people write this null set, saying that there's no possible solution. Okay. Now one can think of the opposite case. Suppose you had a very similarly looking thing as before, but the inequality is the opposite. In this case, actually subtract 2, so it's negative 2, and then divide by 3, it's absolute value of x greater than negative 2/3. In this case, we know that this is always positive. And you're asking this to be bigger than a negative number. So what does that mean? That means it's always true. For any x. Okay? And that means that x can be any number. Any x, so whether x is 1 or 2 or 5 or whatever, you can actually check. Just plug in whatever number, you'll see that this is always true. Say x, let's plug in negative 2. Negative 2 absolute value is positive 2. 2 times 3 is 6. 6 plus 4 is 10. Definitely that's bigger than 2, right? So this is always true for any x, and therefore you can say that the solution is x is all real numbers. Or another way to write the same answer in terms of interval notation would be negative infinity to positive infinity. Okay. All right. Now, let me give you a third example. And this is a rare case where you have an inequality, but the answer is just a single number. So let's say you have 3 times x minus 2 absolute value plus 5 is greater or equal to absolute value of x minus 2 plus, let's see, 7. Oh, no, it has to be 5 for this to work. Okay, so 5. All right, so if you have, it should be this way. Okay, so if you have an inequality like this, if you can subtract x minus 2 absolute value both sides, and subtract 5 both sides, And here's the result. These are like terms, so 3 times this minus 1 of this will have just 2 of this. So this object, you have 3 of them, and now it's subtracted 1. You have 2 of these. This is messy. Let me rewrite this. So I want this to be less or equal to plus 5. Okay. All right. So in this case, we have absolute value of x minus, no, 5 minus 5 is the only thing on the right side, which is 0. Right? And then divide by 2, and you have the following identity. Now, we can use, even if it's 0, if it's equal, you can still use this trick where put that 0 here, put the negative of that number here, right? That's how absolute value inequalities are solved, right? Whenever you have absolute value less than a, you put a and negative a, and you put whatever that's in here over here without the absolute value. Okay? So that's how you solve it. So you can do the same thing, but as soon as you do this, you see that x minus 2 is less or equal to 0 and bigger or equal to 0. What can that be? That means x minus 2 has to equal to 0, because 0 is the only thing that's between 0 and 0. Okay, so x is 2, so that's the only answer. So there are these special cases of absolute values where you might have no solution, you might have infinitely many, and this rare case where you have just one solution.